For thousands of years, people in the northern part of the world have marveled at the spectacular and fearful displays that occasionally light up the night sky. There have been hundreds of stories and theories to explain these celestial lights, what we now know as the aurora borealis, or northern lights. But no one, until about a century ago, suspected a connection with the sun. To be lucky enough to see the aurora is indeed a beautiful experience. As the well-known Austrian explorer Julius von Payer once put it, no pencil can draw it, no colors can paint it, and no words can describe it in all its magnificence. Every northern culture has oral legends about the aurora, passed down for generations. During the Viking period, northern lights were referred to as reflections from dead maidens. The phenomena was often referred to as a vengeful force. In ancient times, most people were afraid of the lights. Other cultures believed it was a message from the Creator. An old tale from the Nordic countries said that God is angry when the aurora flames. In other cultures, it was an omen of impending war, disasters, or plagues. The Sami people called it Wodsahas, the light you can hear. The Eskimos in the northernmost parts of Canada believe that the northern lights were created by spirits, which, dressed in the mystical light, were having fun because the sun is away, that they were playing soccer with a walrus skull. The rapidly moving auroras were called the Dance of Death. The Mandan Indians of North Dakota explained the northern lights as fires over which the great medicine men and warriors of northern nations simmered their dead enemies in enormous pots. The Finnish name for the northern lights, Ravantula, is associated with the Arctic fox. According to a folk tale, an Arctic fox is running far in the north and touching the mountains with its fur, so that sparks fly off into the sky as the northern lights. One romantic conception found in Danish folklore is that these lights were due to a throng of swans flying so far to the north that they were caught in the ice. Each time they flapped their wings, they created reflections, which created the northern lights. The Vikings who lived in Norway 1,000 years ago christened it the Northern Lights. In Norway, children were often told that by waving with white clothing, the intensity of waving increased the motion of the aurora. The first realistic description of auroras is found in the Norwegian chronicle The King's Mirror from about year 1230. It was originally written as a textbook, probably for the young King Magnus Lagabøte by his father. At that time, people thought the earth was flat and surrounded by oceans. One explanation was that the oceans were surrounded by fire, and that auroras were the light from those fires reflected in the sky. Another possibility was that reflected sunlight from below the horizon illuminated the sky. A third explanation was fires in Greenland. Swedish scientist Suno Arnelius suggested that solar rays were reflected off ice particles in the atmosphere, but later spectroscopic analysis of the light showed it was not of solar origin and dismissed this theory. A major breakthrough was made by an eccentric Norwegian scientist, Christian Birkeland, who had a theory that charged particles from the sun could ignite auroras. To prove his theory, he built his own world in a glass box, electrified his model Earth with its own magnetic field, and showed how particles from the sun could ignite auroras. The particles were captured by the Earth's magnetic field and channeled down towards the polar regions. He also showed that they would be identical and simultaneous at both poles. The front of the Norwegian banknote shows a portrait of Christian Birkeland against a stylized pattern of the aurora and the Torella experiment. The back of the note shows a geographic map of the North Polar regions, illustrating the location of the aurora oval. Looking at the sky with the naked eye, the sun seems static, placid, and constant. From the ground, the only noticeable variation in the sun is its location. Where will it rise and set today, and sometimes dark spots occur on its visible surface. This is where the tale of the aurora starts. On the sun, a star of average size among billions of other stars in our Milky Way. The sun acts as an enormous power plant. The energy is created deep inside the core of the sun. Here the temperature is over 14 million degrees, and the pressure so enormous that hydrogen atoms are squeezed together into another element, helium. This nuclear reaction releases energy. The light radiates outward from the core of the sun. In the outer layers, the heat moves to the surface in huge eddies called convection cells. These electrical currents of charged gas create magnetic fields inside the sun. In some places, strong magnetic fields push their way up through the surface. They slow down the eddies of hot gas. The surface cools, and darker sunspots appear. Sunspots can last from a few hours to several months, and a large sunspot can grow to several times the size of Earth. Every 11 years, the sun undergoes a period of high activity called the solar maximum, followed about 5 years later by a period of quiet called the solar minimum. During solar maximum, there are many sunspots, and during solar minimum, there are few. Thus, one way of tracking solar activity is by observing the number of sunspots. However, the sun gives us more than just a steady stream of warmth and light. The steady stream of particles blowing away from the sun is known as the solar wind. Blustering at 1.5 million kilometers per hour, the solar wind carries 1 million tons of matter into space every second. Using satellites, we can image the sun's dynamic atmosphere, called the chromosphere. Here we see bright, intense regions and how violent the sun behaves every second, every day. Using a different filter in the telescope, we can observe the hot corona, where one can see hot gas tracing out the magnetic loops coming out of the sunspot areas. Sometimes the strong magnetic fields near sunspots get twisted and snap. This can release an enormous amount of energy. Such solar flares are short, intense explosions that accelerate particles and intense X-ray radiation into space. Energy equal to 1 billion megatons of TNT is released. Sometimes large amounts of gas are also hurled out into space. We call these eruptions coronal mass ejections, or CMEs for short. They thrust billions of tons of particles at speeds up to 8 million kilometers per hour. During solar maximum, solar storms can occur several times per day, and sometimes they are aimed in the Earth's direction. When the solar storm reaches our planet, something strange happens. An invisible shield, the Earth's magnetic field, deflects the storm. The magnetic fields couple together and create a funnel where the gas streams down on the daylight side of the pole. This is the daylight aurora. The magnetic fields stretch further back and couple together. The magnetic rubber band breaks, and gas from the solar storm streams along the magnetic lines towards the poles on the night side. This is the nighttime aurora. Here is a more detailed view of the particles while they are traveling along the magnetic fields. Eventually, they collide with atoms in the Earth's atmosphere. These collisions usually take place between 80 and 300 kilometers above ground. Here they cause oxygen and nitrogen to become electrically excited and to emit light in much the same way as in fluorescent lights and old-fashioned television tubes. The result is a dazzling dance of green, blue, white, and red light in the sky. The astronauts on the International Space Station have a spectacular view of the Northern Lights. Here's what they can see, sometimes 2 times every 90-minute orbit. The Northern Lights are impressive and different from all other light phenomena by exhibiting an amazing variety of colors, structures, and movements. The best place to see the aurora is, of course, at high latitudes. Auroras are present within a zone about 1,000 to 3,000 kilometers from the magnetic poles, both day and night during the entire year. However, auroras are only visible from the ground during clear, dark nights. Daylight will outshine the auroras. The best period is between September and April. In Scandinavia, the strongest auroras often occur between 8 p.m. and midnight. You should avoid city lights and find a dark place away from the city on a summit or open country with a clear view of the northern horizon. One should also avoid the full moon, which makes the sky less dark. In parts of northern Norway, you can see the Northern Lights almost every dark and clear night. If there's a gust in the solar wind or a strong solar storm, the Northern Lights will extend further south. Sometimes the aurora can even be seen as far south as Europe. Several satellites are observing the sun 24 hours a day, and scientists can detect eruptions on the sun that will produce strong northern lights. By monitoring the activity on the sun every day and measuring the speed of the solar wind particles, scientists can predict the strength and location of the aurora. Thus, by using the internet, you can find web pages that provide aurora forecasting. To capture the Northern Lights with a camera can provide a memory for a lifetime. Photographing Northern Lights is relatively easy. But for the best results, some basic principles should be followed. The best results are obtained with cameras that can be put in manual mode, where you can control shutter speed and aperture settings at the same time. This makes DSLR cameras best suited for aurora photography. Even many compact cameras will also work. When taking pictures of auroras, a tripod is absolutely essential since you need exposure times between 8 and 30 seconds. A fast, wide-angle lens gives the best results. Deactivate the flash and automatic settings. Pre-focus your lens at infinity and readjust if necessary. To take a picture from a ship can be a challenge if there are waves. Since recording the auroras requires long exposure times, the movements from waves can blur the images. You should still give it a try. The best times may be when the ship is moving between islands or the ocean is calm. Good luck hunting the Northern Lights.
back.